Thank you. Is this fine? Too loud? No? Okay. Cool. So thanks for the welcome. My first time in Norway. Very happy to be here, although it's very cold. I'm not used to these sub-zero temperatures. But yeah, today I'm going to be speaking about tips for building custom views on Android with Canvas APIs. And that's quite a bit of a mouthful, so I think I should actually just shorten this title to tips for using Canvas APIs. And the reason why I'm giving this talk today is because I've been working quite heavily with the Canvas APIs for about the past year and a half. And I wanted to share some of the learnings that I've found, and hopefully you'll learn something from this talk because of it. So I first want to get a feel from the audience. How many of you have built your own custom view in Android? Okay, quite a few people, that's good. Okay, so we're going to be going through what custom views are and that kind of thing, and then obviously, so if you've already used one, this might be a little bit boring at first, but we're going to be doing some tips and tricks that I've found when working with it, so hopefully those will help you as well. So what is a custom view? Let's start there. A custom view is basically a UI component that is not part of the stock standard controls that we find with Android, like the material design components, such as like an edit text, a text view, that kind of thing. And this is typically you want to use or create a custom view when the standard Android framework views just don't cut it for you. So maybe you have a designer that's designed this beautiful like bar chart or something like really custom, and you just know when you look at that design, you're like, nope, this is nothing that exists already. So when you want to actually create one is when you have something that obviously doesn't fit the bill, or you can also create a custom view when you want to have a grouping of views for easier reuse across your app. So there's two types of custom views that I like to group them into, and the first one is what I call a compound view or a group of views. And this is basically when you're using already built-in components. So in this example, the custom view I'm referring to is the 4 little arrows at the top of this view. And these are just normal image buttons, right? But this component or this control is something that I want to reuse throughout my app in different tools or sections of my app that I use. So in this case, I would typically extend a view group, like something like a linear layout or something like that, and override 1 or 2 things and group a bunch of things together. And I like to say that this is like intermediate level working with custom views, because you're not really drawing anything on the canvas at this point, you're just grouping things and making it easier to reuse. So how do you do this kind of thing? Well, you basically have a compound view, or you create your view, you can name it whatever, and extend from the group that you want it to be like inflated into. And then you would just normally have your layout file as if you were creating normal XML layout files, and that will have all your normal image view buttons, that kind of thing inside it. And then this compound view can then be reused in any place that you want to use it. So the nice thing about this is that now we can create like an interface or something for anything that extends it, and it groups all this functionality together, and we can then pop it into anywhere where we want to use it, and our XML will all be wrapped up in here and all the custom logic for that as well. But we're not going to go too much into compound views because this is just using obviously built-in views and nothing custom about it really. So what we're going to dive more into is building like fully custom components. So this is when you want to manually draw things on the screen for your users to see. And you would probably be handling your own gestures, your own touch events, your own whatever needs to happen, you're going to be handling it yourself manually in your components. And I like to say that this is a difficulty level of pro level, because this is when you start to need to deal with calculations and all different kinds of maths and just drawing on a screen. So we're going to be diving a little bit more into this one, and the example that we'll be using for some of the things here is a color dropper. So you can see that circle on this view is actually a picker that you can move around on screen, and that is a custom view that we can sort of dive into today. So how would you typically create a custom view? So you would create it with the class name that you want. Obviously, we'd call it like color dropper or something like that, and extend from view. And then we get access to the onDraw method or we can override the onDraw method, and that basically gives us access to this canvas object that'll give us the screen that we want to draw onto. So what is a canvas? Well, a canvas is basically a blank space for you to draw onto. You can think of it like the saying of you have a blank canvas, like the artists say. And that's literally what we have when dealing with a canvas that we can draw on screen. Although it's a bit more prescriptive when dealing with canvas code than in real life. In real life, you can just go and pick up any paints or any technique and just start drawing anything. You don't have to know anything about coordinate systems. You don't have to know anything about that. Whereas on Android, you need to know a little bit more about where you're drawing something to position it nicely on screen. And it's not so easy to draw, like watercolors and stuff like that. So if we dive a little bit into the canvas concept and how it works and like what it's based on in Android, if you dive deep into the internals, you will see that Canvas is based on top of Skia. And Skia is an open source 2D rendering engine that Android uses to render things on screen. And it is based on top of the class called SK Canvas. So if you start dealing with like weird bugs, or you like really need to dive into the internals of what exactly this canvas is doing on screen, you can go and dive into the source code of Skia and have a fun time reading all the C++ and everything that's in there. But the point of this is that a lot of the canvas code that you work with on Android is very similar to canvas concepts on other platforms. So the web has a similar canvas object, and a lot of the functions and methods that you call are very similar in how they work and what they do. So what we learn here today will probably translate pretty well to other contexts, even such as like iOS and the web as well. Okay, so let's talk a little bit about the canvas coordinate system, because it might be different from something you're working with. So for instance, when you're working with a canvas, you need to realize that the top left corner of your canvas is the point 0, 0. And that is the starting point. So everything that is drawn in is placed relative to this 0, 0 starting point. And if you work with a canvas, you need to realize that everything you draw with any of the canvas drawing commands, you're drawing with pixel values and not density or DP values. So this might be a bit different from just like working with text views and stuff like that, where you're putting it in XML and it automatically translates to the correct pixel values on screen. You need to do that translation manually yourself. And then another thing to realize about the canvas is that everything that you draw, the drawing commands are executed on top of each other in order. So you won't get like a linear layout kind of functionality. You have to do that measuring and all that yourself. But this will probably just produce a stacking effect if you don't measure and manually lay it out where you want it to happen. Okay, so how do we actually use a canvas in Android? So you need to do 4 things in order to get something to draw on a screen. 1, you need a bitmap or a view to hold the pixels on screen. 2, you need a canvas object, like what we had with that view that we created. And this will host all the drawing calls that we're going to show on screen. Number 3, we need drawing commands. So this is describing what we're going to draw on screen. And then number 4, we need the paint object, which describes how to draw the command on screen. So the color and that kind of thing. So if we understand what a canvas is, we need to obviously want to draw on top of it. So how can we draw on a canvas in Android? So there's a bunch of different commands in the canvas class. If you go have a look, there's like probably over 50 or so methods. So I won't be going through all of them today. That would be very boring, but we'll go through like 1 or 2 and just have a look at the most commonly used ones. So the first one is to draw a bitmap. So to draw a bitmap on screen, we have this canvas.drawBitmap method. It takes in the bitmap that we want to draw on screen. So in my case, it's a Toy Story image. And then it takes 2 other parameters, which in my case I've set to null and destination rect. So null, the second parameter, describes what portion of the bitmap you want to draw on screen. So if you only want to draw a certain portion, you would specify it. If you want to draw the whole thing, in this case, we say null. And then the destination rect is something that we specify the rectangle of where it's going to be drawn on screen, and the size and its sort of aspect ratio. And then the paint object describes how we're going to draw it on screen. So in this case, we're not applying anything fancy, probably just an anti-alias flag, which we'll get into, but that's the 4th parameter that we pass on to. But drawing bitmaps on screen is actually quite tricky on Android. It can be quite easy to produce something like this, where you stretch it out of proportion and it just doesn't look good. So you need to manually make sure that your rectangle that you send to the canvas is already in the correct aspect ratio and the correct size and place that you want it to be drawn on screen. And then one such way to make sure that this works properly is to normalize your canvas values. So we'll dive a bit more into what that means a bit later, but just to get your aspect ratios and all that kind of working, it's nice to be able to work on a canvas that has been scaled and translated into the coordinate system that you know and work with. Okay, and then there's two other Canvas APIs that I use quite often. So another one is DrawRect, so that just draws a rectangle on the canvas. And you can see this example again of the color dropper. That little rectangle in the middle, this might be very hard to see from the back, but that's just a rectangle drawn with white paint at that certain coordinates. And then draw a circle as well. You give it an X and Y, so the position, the radius of the circle to draw, and the paint that it must draw on screen with. And I'm not going to cover any more Canvas APIs. We'll be diving more into the paint object and looking at what we can do with the paint object and how to work with it. So in my opinion, I think the paint object is probably the most fun to work with because there's so much it can do. There's so many different things that can unlock for you, which you don't really kind of think will happen with a paint object, but there's many cool things you can draw with a paint object. So in this case, a paint object holds information and for how to draw something on screen. So in the case of drawing text, you can set a color, you can set things like shadows and that kind of thing, and the typeface. But in this case here, we just have a paint object that is set with the color red, and it has a style of stroke. So you can do stroke or fill, and that'll obviously fill in your circle or just draw the stroke around it. And then probably the most important about a paint object is there is anti-alias flag. So that will tell your canvas to draw things with smoothing. So if you don't have anti-alias turned on, you're probably going to get very jagged edges if you're drawing a bitmap that's like a little bit rotated or something. So if you start to see weird jagged edges on your things, you probably haven't enabled anti-aliasing. But Paint can also store other things such as letter spacing, your typeface that you're using, so the font that you've chosen, and the text size, that kind of thing. But also, interestingly, it has this method called set shadow layer, and that allows you to create a shadow. We'll go a little bit more into how this works in a few slides, but just remember you can set a shadow layer on a text paint as well. Okay, but what are some of the cool things? Like I said, that paint is my favorite object. Why? Well, there's a whole bunch of cool stuff you can do with a paint object, and one of them is to use shaders with paint. So this example, again, of the color dropper is using a bitmap shader. And how that works is basically you pass it in a bitmap. So in this case, the bitmap is the background or the whole project that is rendered on screen. And the color picker is showing like a zoomed in version that is only that certain section of the bitmap. And that is showing using this bitmap shader. But there's a whole bunch more shaders that you can use. There's things like a radial shader, gradients, that kind of thing. So it's really, really powerful in what you can do with it. But let's dive a little bit into how we can use this bitmap shader on this example here. So in order to draw only that certain part of the bitmap on screen, we create this new bitmap shader, and we pass it in the bitmap that we want to show, or that project bitmap that we have. And then on our paint object, we set the shader to this bitmap shader, okay? And this will then do the magic of drawing that on screen for us. But we wanted, if you remember from that previous example, that bitmap was actually zoomed in at that certain point, right? It wasn't just like the exact copy of the image, because that wouldn't show any cool effect. So in order to zoom it in a bit, we create a matrix, and we'll discuss a little bit more about what a matrix is, but you can think of it as basically it's just scaling that bitmap now at this point. So we pass in the scale that we want to scale it up to, so maybe 3 times, 4 times, and the point on the bitmap that we want to scale it at. And then we set the shaders matrix to this matrix that we've just created. And then to draw that zoomed in bitmap, all we need to do at this point is say canvas.draw circle with the point that we want, so X and Y points, the size of the circle, and then the dropper paint. So the paint has already got all that bitmap information set on it. It's already got it scaled in. So whenever we call draw circle, it's now going to have that bitmap that is zoomed in at that certain point. And it just creates that cool zoomed in effect on this view here. Does all the clipping, all the masking, everything else around for you already. Okay, so working with the Canvas code can be quite daunting and quite confusing at first. But one tip I have is to use KTX for getting a bit more cleaner code when working with the Canvas. So what is KTX? So KTX is basically a core set of extensions provided by the Android team at Google. And it's for Kotlin when you work with Kotlin. So only if you're working with Java, unfortunately, you can't get access to these, but it makes everything a little bit nicer to work with. There's a whole bunch of extensions in there, not just the ones that I'm going to talk a little bit about today, but definitely take a look at the extensions that are provided in there because there's a bunch of really nice ones. So let's take a look at a typical scenario that we would do with a Canvas object. So there is a save and restore concept on Canvas that allows you to checkpoint your canvas at a certain state. And basically when I call save, we get this checkpoint, and we know that anything that we do within the save and restore will only be done or only work for those certain commands that are happening inside there. So in this example, we have canvas.save, and then we call canvas.translate with 200, 300, whatever your values are. And then we call draw circle. Okay, so what this will do is it'll actually just move the circle by X and Y amount and draw it at that certain translated point. And then we call restore. And now every command that happens after that restore won't be translated anymore. So at this point now, we have an untranslated canvas, but it's quite hard to know that that is the case unless you really understand how the canvas works and all that kind of thing. It can also get quite tricky if you have a lot of these kind of commands, like translate, rotate, save, restore, happening at different points. It can be confusing to know at what point your canvas, what it looks like at what certain point. So if you use something from the KTX library, it looks something a bit like this. So there are these methods like with translate, with scale, with rotation. And you call canvas.withTranslate and you give it your values, and that performs the actual save and restore for you. And then everything inside your block after that will be on that translated canvas. So this is a little bit, in my opinion, a little bit easier to read and understand that this canvas is now at this certain translated point, and we still get the same effect of the canvas being rotated and translated. So taking a look at a little bit more of a complex example, here we have a square or a rect and a circle, and now we have the save and restore happening at a few points. So we first translate, then we draw the circle, then we rotate the canvas, then we draw the rect, and then we restore the canvas to certain points. So in my opinion, this is a bit harder to know exactly where the rect will be drawn. Whereas if we look at the KTX implementation, we first translate, we draw the circle, we rotate, and we draw the rect. And now you can see exactly that the rect is going to be drawn at a translated and a rotated point. So in my opinion, this is a little bit easier to read and makes it, if you have a really complex canvas code, this can make it a lot cleaner to read and work with. Okay, another tip I have for working with canvases is to use the matrices class to make canvas operations easier. So what is a matrix class in terms of looking at Android? Well, a matrix in Android, the Android graphics matrix, not OpenGL1, is a 3x3 matrix for transforming your canvas or coordinates. So you can do cool things with the matrix such as scaling, skewing, rotating, translating, or even perspective drawing, which we'll get into as well. So how do I use a matrix on Android? Well, you just create a new matrix class and you apply your transformations to your matrix. So in this case, we're going to post-rotate the matrix by 20 degrees. And then to use that matrix, we can just call canvas.widthMatrix and pass in the matrix that we've just created. And then every command that is within that block will be drawn on that matrixed, or that rotated canvas at this point, because the matrix has done that. But we can also do other things, such as like apply a rotation, a translation, that kind of thing on a matrix. So one cool thing that I found with working with a canvas is to do, how do you do like perspective drawing using it? So there's this method on a matrix called set poly to poly. And basically it takes a source array and a destination array, and everything in that source will map to the points that are in the destination array. So once you've set that on your matrix, we'll show a little bit more about how those matrices or those float arrays work. But once you've set that, you just pass your matrix again and draw it, and then you'll see the picture here is drawn in a little bit perspective drawing. So if we look at that source and destination array, you can see the first point, so it's actually just a float array, it's not like a vector or like an array of vectors or something like that. It's just plain array, but the coordinates are matched in pairs. So the first two here are 0, 0. So the source, whenever something is drawn at 0, 0 point, it'll map to the point 50 to minus 200. And that's the same for all those different coordinate pairs within this source array will be mapped to the destination array. So if you could look at that Toy Story example again, initially it was drawn, the corner was drawn at 0, 0, but because we applied that matrix with that transformation of the set poly to poly, it translated that 0, 0 point to 50 to minus 200. And that you can see, you can get this cool like perspective effect. So you could probably put some like gestures on top of this and like allow users to move their image around and make some cool distorted images if you want. Okay, so the next thing, how do I work with two different coordinate systems? So when working on a canvas in Android, it can be quite difficult because your view size is dynamic, right? You have different size devices where you probably get different size measurements, and this can be quite painful to work with, especially if you're trying to draw something really complex and you want to know the measurements and exactly, you want to position it in the same place on all different screen sizes. So how do we work with this? So we typically, in this example, we have a measured view width of 1080 and a height of 2180. So this is not something that we can rely on. We can't like hard code this kind of value, but we can, in our like concept of how we draw, we can work with certain sizes, such as between 0 and 100 or 0 and 1 if you wanted to. And that makes things working with that a little bit easier instead of working with this dynamic size that we don't know how to deal with. And in my example, and like the things that I work with, we have something that's like a custom size that's inputted by the user. So they can choose a canvas that is like 2048 by 2048, but we don't know what the size of the view is on screen. So we need to be able to like map between these two coordinate systems. So like my one that I understand and I work with, and then the one that is on the view that is shown to the user. And it can be quite tricky, and I kind of feel like that when I work with coordinate systems, especially the ones displaying on screen, because you have to do these translations a lot of the time. So my advice for this kind of thing is to scale and translate your canvas very early on in your rendering. So if I have a size class, for instance, that has a value of like 500 by 500, and I want to fit it within this view on screen, right? I have a function called fit center, and that takes in the canvas size, so the canvas size of 2108 by 1080. And then we get a scale and an X and Y that we need to translate by. So what we do at this point is translate the canvas, so translate it by X and Y, and then scale it up or down to the size of the view that needs to happen. So if I have a 500 by 500 and I need to scale it up, it's probably going to scale it by 2 or 3 times to get it to render on screen in that exact size and format. And now, at this point on, any canvas operations that we do within that are going to be at that scale, and you can work within your coordinate range. You don't have to worry about working with the measured size on the screen at this point. You can work with what you know. And this helps us avoid having to scale all our values everywhere and like keep track of the scale and make sure that we're scaling it where we need to. Okay, another thing that we can do with Canvas and working with coordinate systems is to map between these two coordinate systems, right? So in this example, I have the view of the size of my screen, and then I have an image or a bitmap drawn at that rotated point. And the red dot is where a user has touched on my screen, okay? And when we get a touch point or like a gesture or something from the Android system, it's obviously not going to be in your coordinate system because Android doesn't know about that, right? It's in the view's coordinate system. So what I want to do is I actually want to get the touch point on inside that bitmap, like translate this point from a view touch point to a point that is within inside this bitmap. So it's actually going to be at that rotated and scaled down portion. So how do we do that kind of thing? Well, you can use a matrix to do this. So this method basically takes, it's called map point, it takes a point in that'll be part of the view, that'll be a view coordinate, and then returns a point that is like what I know and like what's within my domain of knowledge. So to do that, I need to take a matrix and I can rotate, so post translate, post rotate, with the transformations that I've applied to that image as well. Possibly a scale if I wanted to, but basically you can apply all your transformations to that matrix. And then you can create a float array with the touch point that's come in, so the X and Y. And then on a matrix, there is this method called map points. And that takes in your array and basically in place, it substitutes and applies those transformations for you on that matrix to those points that have come in. And then when you get those points out, after doing that map points, they will now be within the coordinate space that you are aware of and you know what to do with. So you can do cool things with this, like knowing exactly or drawing on that bitmap if you wanted to, that kind of thing. Okay. Another tip that I have is to check that the Canvas APIs that you're using work across different API versions. So remember the shadow layer stuff that I mentioned at the start? Well, this gets quite interesting because if you start using it with draw text, it works pretty well. You can see a shadow, you can apply a blur, you can apply a color, and it works and it draws on the screen pretty nicely. But as soon as you start to use this with a draw bitmap command, and hardware acceleration on or off, you get like interesting results, okay? And I'll show you an example of what that looks like now. But it also, if you use the draw path command, it also doesn't work 100% with that either. So there's also some weird results that you might see when using that. So this is an example of using set shadow layer on a paint object. And on API 26 with hardware acceleration on, we set shadow layer on this paint, but you can see the Toy Story image has no shadow, okay? And then the other example is on API 28, on hardware acceleration turned on. You can see that there is a shadow, but in my opinion, it's not really what I expect from a shadow. It's like a duplicated version of the image, and it's got blurred edges, which I guess is kind of a shadow. But if I set the shadow color to black, I expected that background to be black, which it's not. So this is also the result if you turn on or you turn off hardware acceleration on API 26, so you get this strange shadow on these examples. So this brings me to checking or working with hardware and software rendering. So if you create a canvas off screen, so you can create a canvas with a bitmap that backs it, it's always going to be software rendered, okay? And if you create an on-screen canvas, like you're displaying a view on screen, it's going to be either hardware or software. You can choose what you want it to be rendered as. And if you want to disable hardware acceleration on a view, you can just, in your initializing or your constructor, you can say set layer type with the type software, and that will then use software rendering to do it. And you probably don't really want to disable it, but maybe you want to for like testing purposes, but generally you want to leave hardware acceleration on if you can. Okay, but now let's get back to this paint issue, right? We've got this method that works on a paint object, but it only works on text. It doesn't work on bitmaps. It's very confusing. So there is this guide online, or I won't say guide, it's just a table, but it basically shows you the supported hardware methods from a certain API level. So even though the methods exist on the canvas or on a paint object, doesn't necessarily mean it's going to render it on screen, okay? It's also not going to crash in certain stages. So it might just not render exactly what you're expecting on screen. So this little graphic or table, it's really hard to see, and don't worry about the contents, but basically it shows you the certain method call and its API level availability from. So if you're seeing weird different results, go check this table and make sure that the actual support is there for your API level that you're working on. So the conclusion of that is that you should test your custom canvas code on different API levels. So if you support down to 19, then you probably want to run it on a 19 device and on all the different ones as well, just to make sure you know which version is running which set of canvas calls. Okay, but let's take a little step back, and I get asked this question quite a bit from a few people. So people ask me the question of, okay, this is cool, I know that you use a custom views, but when should I use a custom view versus a fragment or an includes directory file or tag? And this is my answer. It's not necessarily like the correct answer. I think this is a matter of opinion, but this is how I kind of go about deciding if I want to use a view, a fragment, or includes tag. So if I want to use a custom view, when do I choose to use a custom view? So I choose to use a custom view when the built-in components just don't cut it. So I need to do custom canvas drawing or custom gesture handling. And this is obviously like a no, you've got no real other choice when you're doing this kind of thing. Like if you see something that's not part of the Android framework, you have to kind of go this route of getting access to a canvas and drawing that on screen. I also use a custom view to encapsulate logic and expose a callback listener for a reuse of that component. So if I have a component that I want to put in different portions of my app, but I want to get access to like maybe the gesture when it ends or something like that, I want to get notified, I create a callback and then reuse that custom view at certain points. And this is also when I don't want like users of my view to be concerned with the internals of how this view works. So I don't want them to know like the gestures and how they deal with it. I just want them to be notified when the gesture's finished or like when the interaction with the control is done. So when do I decide to use a fragment? So a fragment I basically decide to use when it's a whole logical component within my app that's mostly standalone. Okay, so I don't need custom drawing, for instance. I'm going to default to a custom view if I have to do that. And I'm probably using like built-in components, or I'm embedding a custom view inside that. And I think one of the most important thoughts when I do think of when to use a fragment is when I don't really need other callbacks to other parts of the UI, okay? So if I have a fragment, it's not going to be saying, okay, this interaction finished, this interaction started, that kind of thing. I use a custom view for because that will be embedded inside a layout that'll use it. So the fragment is like the whole logical component that I use. And then an include tag. So this is basically just to reuse your layout. It's not to reuse, like you won't get support for all the gesture stuff that you've done and any sort of like encapsulation of like how this component works. You won't get if you have an includes. An includes is basically nice to use for like a toolbar if you want to just like repeat that. And it's literally just a bunch of layouts that are grouped together. And this I use when I need individual access to each component in my layout. So if I don't, if I want to be able to access the toolbar and set the title or like views that are reused, and I want to do some stuff with that, then I'm going to go with this route. And there's no custom logic around touches or drawing with this. Obviously, it's just views included in your layout. And I'm going to be manually handling all my component logic myself. I'm not going to be wrapping it up in a custom view if I use an includes. Okay, so at this point, you're probably thinking, well, the Android team just announced that they're like scrapping the UI system with Jetpack Compose. So like, what does this leave me when I look at Canvas drawing, and how does that work? So for those that don't know, Jetpack Compose is a new declarative UI toolkit for Android. And it is basically, it's still in beta or dev, I think, it's not even in beta. So it's strongly advised not to use it in production yet. But basically this whole system has been inspired by the like React world and Flutter and Vue, and how they create these sort of virtual DOMs to render things on screen. And it's quite a like different mindset when drawing things on screen. Like I mentioned, pre-alpha, not ready for production use yet. And the sort of like drawing card is that it's unbundled from the platform. So I think we've all seen the benefits of using like things that are not bundled with the platform, like Recycler View. If you can like use it where you bundle it yourself, you get access to all the updates. Whereas, for instance, the Canvas class, like you've seen with all these weird things, is that it's bundled with the platform. So you can't update or fix any bugs on certain API versions. What you get is what you get. So how does Jetpack Compose work? So this is an example from the docs. So this is the basic, like what it does. And basically you annotate your functions with this @composable annotation, and you pass it in the whatever you want. So you can create all these cool things. There's a text item. This may have changed with a new release. I'm not 100% sure, but this is what basically like the idea of how it works and how it looks like. So at this point, we would just have a text view drawn on screen with the word hello and then your name that you've inputted. So this is cool, and does this mean that I don't need to know how to draw something on screen because this is going to solve all my custom view problems? Maybe, if you are just doing basic things, but you're probably still going to need to use a canvas at some point if you need to work with like a custom view that you're drawing on screen. So this was also an example that I pulled from one of the example apps, and this is to draw a rectangle on screen. So there might be nicer APIs now with the newer release, but this was one of the sort of base examples where you get this draw command or draw composable function, and you have this canvas that you get access to, and then you can still do the same canvas things that we've just learned throughout this presentation. So in my opinion, even though we're moving forward to Jetpack Compose, knowing and understanding how a canvas works and working with that is still going to be valuable, because at some point you're probably still going to be drawing something custom on screen. Okay, so some final thoughts. So when you're working with your canvas, try and normalize your coordinate system so you don't have to like constantly translate between these two systems. And then use a matrix class for easier transformations. We saw how you can apply a bunch of transformations to a matrix and you get out this really nice working solution. You can map points, stuff like that. So matrices are really powerful. And then the sort of downside is double check that your canvas features are available on the APIs that you're using, because as we saw, shadow layers, stuff like that, there's a whole bunch of those APIs that just don't work, and unfortunately, you need to test it for all API levels. And then use KTX. So we saw that it has all those cool, with translate, with scale. There's a whole bunch more, like working with colors, that kind of thing. So definitely take a look at the KTX extensions. And then last thought is that the canvas concepts are not going to be disappearing anytime soon. Even though we're going to get this Jetpack Compose, you're probably going to still want to draw something custom on screen. Maybe it's just done in a bit of a different way, but the concepts are still going to be very similar. And that is all I have for you today. So thank you very much for taking the time to listen.